All right, we are recording right now. Hello, everybody. Derek Demeter. We have Frank Kane, our chief engineer of the telescope operation. That's actually how he sees the night sky with his telescope. Not really. And then here we have
Yes.
Commander Cirillo. He goes by Justin or Commander Jason.
Lately, Jason. Yeah, I guess I must look like a Jason because I've been
Yeah,
getting that a lot.
anyways, I'm going to go ahead and go live on Facebook right now, too. So we're going to do another introduction for that. So we're trying to do this at the same time. So we're starting the recording a little bit first, and then we're going to go ahead and initiate the Facebook Live here soon. So we're going to go into more detail about what we're going to be doing for the Star Party in just a second once you get the Facebook. All right, looks like we are officially live on Facebook. Hello, everybody. My name is Derek Demeter. I'm Captain D of the Virtual Star Party. We have Chief Engineer Frank with his astrovision goggles, or
Reporting for duty.
reporting for duty. That's how he actually sees through the telescope, or maybe not. I don't know. And then we have Commander Justin at the helm here. He's going to be
Yes, sir.
he's going to be our guy that is kind of controlling the Facebook Live, as well as making sure that if you have any questions for us throughout our virtual Star Party, we'd love to hear from you on that. So definitely don't feel shy to ask us questions. There are no stupid questions. There are only just inquisitive and awesome questions, and we'd love to hear from you. So what we're going to do tonight, we have a couple of things going on, though. Commander Justin has mentioned to us that right now the weather report doesn't look as great as we hoped. However, we like to be proactive here at the Virtual Star Party, and that we do actually have some images that Chief Engineer Frank has taken images of using the same telescope that we use during our live star parties to show you some of the objects we would have viewed. But you never know. Florida's weird. Florida can get clear all of a sudden. In fact, it just cleared up. We had the opportunity to look at Venus and the Pleiades. I was able to get a quick shot with my camera, and we'll be able to share that with you in a few minutes here. So you never know. It could be surprising. Frank is still going to probably point the telescope at stuff, right, Frank? And hope that maybe we might see something?
We'll see something, and yeah, we're going to try.
You know, we'll give it a try. We'll give it a shot, no pun intended, and see what we can see. That's the beauty of live virtual programs and star parties. No matter if this was in virtual or not, the weather changes very, very quickly, so we have to adapt to it. But thankfully about virtual star parties is we can actually show some of the images that we have taken in the last couple of days, the same objects. So no matter what, we're going to show you some really cool stuff tonight, and we are excited that you're here and enjoying us. But before we do that, we're going to do a little bit quick tour using Stellarium of some of the objects we're going to be looking at. So that what I'm going to do now is I'm going to go ahead and share my screen. All right, and I'm going to go ahead and start looking at the night sky. So here we are. The time right now is about 9 o'clock. We'll go to 9 o'clock. Why not? Yep, about 9 o'clock. This is pretty much the sky you're seeing out right now. And right now we're facing south here. But the thing I want everybody to do, if you have an opportunity right now and it is clear outside, take a few moments and look at this object. If you have a pair of binoculars, I strongly recommend that you go and grab a pair of binoculars because it is fantastic. And if you look over in the west, you might see this incredibly bright object. It's the brightest object in the sky outside of the moon right now. And that is a planet. That is the planet Venus. And so what I'm going to do now is I'm going to go ahead and center on that object. We're going to go ahead and zoom in here, and you're going to notice something really cool about Venus tonight. First off, Venus is the second planet from the sun, and it is much hotter than planet Earth. Actually, the average temperature on Venus is over 800 degrees. Yes, you heard me right, 800 degrees, very, very hot planet. So it's a much different type world than the Earth is. But I want you all to focus your attention to this area right here to the right of Venus. This is a cluster of stars known as the Pleiades. Yes, the Pleiades, the Seven Sisters. Or if you're from Japan, Subaru. Yeah, that's, if you ever look at an emblem of a Subaru, it's basically the Pleiades. And there's a lot of lore to the Pleiades. Believe it or not. For example, the ancient Celtic people saw the Pleiades as a weakness in our physical world to the spirit world. So when it would rise in the sky in the fall, they thought that was a time when the dead could rise and walk amongst our lands. The Japanese actually saw these as seedlings that would start to appear right before the sun around springtime, when we would be able to see, when we would start growing things and stuff like that. So, but anyways, here we have the Pleiades and Venus. And if you have a pair of binoculars, go outside right now and take a look at these two objects. It is incredible. I know, Commander Justin, you did that recently, did you? Did you go out there, bring your binoculars out?
I did. We ran out about 10 minutes ago, and I'm in Maitland, and there was some faint clouds in front of it, but I was able to make out most of the Pleiades, and Venus is just spectacular right there. So we've got time. We've got, this show's an hour. We're still going to be able to see. Venus is not going to move that much over the next hour. So even if you have to wait till after the show, just get outside and take a look. Hopefully, if you've got binoculars, use them. This is pretty neat to be able to see these two objects that most astronomers look at all the time, much further apart, be right on top of each other.
Definitely. And so definitely go out there if you can. If you're not in Central Florida and you have really clear skies, or if you're in Central Florida and you have a little bit of a haziness, but you can still see Venus, go out there. And what I was able to do recently was I was able to actually take a quick picture of Venus and the Pleiades. So this is an image I took with my camera, and you can see this really bright object right here. That's Venus. Now, Venus has very reflective clouds, and the entire planet is covered in these very reflective clouds. So when the sunlight hits Venus, these clouds reflect a lot of their light out into space, making it super bright. You might have been in an airplane and past the sun hitting a cloud. It's super bright. It's hard to see. You gotta wear sunglasses or polarizing glasses. But anyways, Venus is so bright, so that's why it looks really, really bright, because this is over about a third of a second exposure. But you can see here, we can see the Pleiades right here, the seven sisters right there in the sky. So you can see there we have the seven sisters. Now, the seven sisters actually are more than just seven in this, actually. There are hundreds and hundreds and hundreds of stars, thousands of stars in this cluster, and but we only see the seven brightest ones with our naked eyes. But if you were to actually look at that with a telescope, you would be just filled with all kinds of stars. So there you have it. There we have Venus and the Pleiades. And so what we're going to do
when
now...
you do look at these guys...
Yes, yeah, definitely go out and take a look at these guys here. All right. So I'm going to go ahead and bring that down, and what we're going to do is we're going to go ahead and look up above us, almost directly overhead this time of day, and you're going to see the moon. Yes, we're going to see the moon. And that moon right there is gorgeous tonight. And what we're going to do is we're going to have an opportunity to take a look at the moon using our telescope tonight. So Frank, are we still able to see the moon tonight?
Yes, we can. We got lucky, and we got a little bit of a break in the clouds there, and I did manage to get a good picture of the moon just now. Want to take a look?
All right, let's go ahead and take a look.
All right, I'll share my screen here. And there we have it. Yeah, so you can see the live image of our telescope there on the left there pointing at the moon, and to the right here is a picture that I just took with it. So it's looking pretty good tonight. It's a pretty good phase right now. You can see some nice little details of the craters down there around what we call the Terminator, right? I don't really know my lunar geography very well, but if you know any of the ones that are here that we can talk about, go for it.
Yeah, we can see right there, the one where your mouse is hunting over. That's it looks like it could be, I believe, Plato, maybe. No, that's Tycho, maybe. Yes, it's Tycho. It's weird. It's a weird angle to see the moon there. I think that it's actually. Go ahead and leave in the comments if you know exactly the crater in this image. Do we have anybody that's telling us, Justin, on the Facebook?
Not yet, no.
All right. The one right over here, if you scroll your mouse down towards kind of one of the large Maria, areas in the bottom end there, you will see Copernicus. Yep, that really big crater just to the right a little bit, to your right. That one right there, that is Copernicus. And Copernicus is a large crater over 50 miles in diameter, so you could fit most of Central Florida inside of that crater right there.
Whoa.
That's pretty epic right there.
Yeah.
Well,
It's
while
super
you're
good.
on the moon, Derek, why don't you just go over the Mare themselves, just to
Yeah, so
give people kind of an idea.
yeah, so those dark spots on the moon, those dark blotches on the moon, are basically ancient lava basins on the moon. So long time ago, billions and billions of years ago, the moon, as it was slowly cooling down, was still fairly hot and molten underneath, but it created a nice thick layer of crust. But what happened is when how the moon formed was an object called Theia actually hit the Earth and caused this massive debris field to surround the Earth. And over time, slowly what happened is the moon started forming from this amount of debris. And what you get is essentially you get a debris ring that eventually would form the moon. And then from there, as the moon started growing bigger and bigger and bigger, pieces of other debris would be gravitationally attracted and all of a sudden would hit the moon and create those craters. And a lot of those larger pieces hit the moon and form these large lava basins that we see on the lunar surface. Those are those Maria. And the word Maria means seas, right? It's a Latin for seas. And so the early astronomers thought they were oceans on the moon. So that's why we call them Maria. And many of the Apollo missions that landed on the moon landed in these basins because if we study those areas, we get a better idea of how old the moon was, and all these, and the geology of the moon, and the many different types of metamorphic and igneous rocks that we find on the moon. So the Maria are gorgeous to look at. That gives us the profile of the man on the moon or the rabbit on the moon or all these different profiles we get. And as we continue on into the following phases, we'll start to see more and more of what we call the near side of the moon. We always see the same side of the moon at all times. And that's what we're seeing here. We're seeing the near side because the moon is gravitationally locked to the Earth. And so we always see the same side of the moon as it goes around the Earth. Now, there are pictures of the far side of the moon. By the way, there is no such thing as the dark side of the moon. I know Pink Floyd would like to tell us that, but that's not the case. There is no dark side of the moon. Both sides of the moon get the same amount of day and night. We just do not see that here on Earth. So yeah. So that's a little bit about the moon. Frank, if you want to move your cursor a little bit more, keep going to the left a little bit, to the left, up, up, up. I love this. This is fun. Keep going up to the next Maria. That one right there,
There we go.
I know what you're doing. Yep.
And that is the site of the Apollo 11 landing. So, Mr. Justin, you probably have your sights on that, right? To go there at some point for a future national park on the moon, right?
Well, yeah, absolutely. We got the Eagle right here, landed right there in that spot 50 years ago. And it was really cool. We had gotten rock samples during our Moon Week event, and 6 different types of rock samples, a lot of the basalt. Those lighter portions that you see on the moon, those are highlands filled with a rock called a northocite, and we were able to get samples of that from NASA in our crafty little high security briefcase. It was just a fantastic week, but lots of cool stuff. Looking at the moon, it never gets old. Every time you look at it, it looks a little bit different because of its wobble, the different phases that it's in. It's a gem to look at. And even if you have the most rudimentary telescope, even if all you have are binoculars, you can make out these mare, you can make out these highlands, you can make out these deep craters. The amazing thing about the moon is a lot of these craters are just incredibly deep. 10,000 feet deep when you look at these. And like Derek said earlier, just looking at them from here, they don't look that impressive, but the moon is about the size of the United States of America. So if you put that in perspective, these craters that you're looking at, Tycho and Copernicus, like Derek said, they're the size of Central Florida, 90 miles across in some instances. So the terminator line, this is where day and night meet. Frank mentioned that earlier. That line where day and night meet, you can just pick up incredible detail of the sun hitting peaks, incredible shadows inside craters. So just highly recommend anytime the moon's out. We got a super moon coming up, and that usually gets a lot of excitement. But honestly, that's one of the worst times to look at the moon in its detail, because it's just so bright. So right now is a perfect time, and a crescent is another great time to look.
Definitely. So we definitely, excuse me, the moon is always a treat to look at in the sky. So I definitely recommend all of you at some point to grab a pair of binoculars, grab a telescope, and you can spend literally your whole life looking at the moon. There's all these little ridges and valleys and mountains and just little shadows. And depending on the phase of the moon, each day reveals some new certain feature that can only be seen on that particular day. So you can really go out there and spend a lot of time looking at the moon. The best part about the moon is you can view the moon pretty much from anywhere on Earth. No matter where you are in light polluted skies, in the middle of a big city, you can always see the moon. Of course, the problem with the moon, though, is that the moon produces a lot of natural light pollution. So even if you're in the darkest places on Earth, when you have the moon up, it's like being in the city. So really, the moon, unfortunately, isn't the best exact time to look at objects in the night sky. Because of the fact that, all this natural light pollution. But thankfully, Frank has special filters that actually help with reducing some of the visibility. Frank, do you want to talk a little bit about some of the filters we can use to help us see some dark and deep space objects?
Yeah, so let me stop the share here so I can get back control of the screen. Yeah, so
Frank,
what we can do...
make that image, can you make that full screen?
Yeah, that's what I'm trying to do. There's sort of some fighting going on between Zoom and my my screen here. Let me see if I can blow that up.
Getting a lot of
while I'm doing that,
to zoom that.
Let me
Zoom on Zoom.
Yeah, exactly. I'm just trying to reconnect to it here. But yeah, like there are some special filters you can use with astronomical cameras to actually filter out some of that light pollution if you're imaging from a suburban location like we are here. So there's a little trick you can use in that. Oh, wait, this looks good. I think I'm going to share again here. There we go.
There we go. Engage.
Yes, that's better. That works better.
That looks fantastic.
Yeah, and this is a high resolution camera, so we can actually like keep on zooming in if we want to too.
Yes, enhance. Enhance.
Yes, indeed.
There are mountains inside these craters, ladies and gentlemen. So
yeah, the mountains.
Craters inside craters.
Meta craters.
It's like craterception. But yeah, just to finish that thought, you can use a trick in that a lot of the nebulas that you see in deep space emit certain wavelengths of light based on the chemistry that's going on inside of them. So we can use special filters that only let those specific frequencies through. And by doing that, we can just let through the light from these beautiful distant nebula that are in our galaxy and filter out all the light pollution and garbage that's in the sky alongside with it. So there are ways you can actually get really good astrophotos, even from a suburban or even an urban location, using these techniques.
It's amazing the technology that we have available to us. Even just 10 years ago, doing some of this was just impossible. So it's really opened up a lot of opportunities for us to really to explore objects in the night sky. So definitely, don't feel, if you feel like, man, I'm in the middle of this really, really dark place, or not in a really, really dark place, and you feel like, oh man, I'm not going to be able to really do anything with the telescope. There are options. There are options, especially with certain cameras these days are very sensitive, and they can really do some amazing stuff with the with your telescope. So But thankfully, we have all this equipment. So what we're going to do now is we're going to take a look at some of those other objects that we can see in the sky. So I'm going to go ahead and start sharing my desktop again, and we're going to go ahead and we're going to zoom out a little bit here. And we're going to go ahead and take a look at some of the objects of the sky. What we're going to do, focusing on tonight, is we're going to be focusing on a part of the sky we call Gemini. What I'm going to do now is I'm going to bring up some constellation lines as well as some labels for the constellations. Now, last week, if you were tuning in, we looked at Orion the Hunter. So here's Orion with the 3 stars of Orion's belt right here. We have Betelgeuse, that bright red star above there. But if we continue going up from Betelgeuse, we will eventually see 2 stars side by side right here. And this is Pollux and Castor right there. And there's Castor. And Castor and Pollux make up basically the head of the Gemini twins. And there we have Gemini. There's Castor and Pollux right there. They're all hanging out and definitely not practicing social distancing right now. In the sky. They should probably be feet away from each other. But, you know, I guess they don't have to worry about. One's immortal anyway, so I guess they're all good. But anyway, so here we have Castor and Pollux, and to be honest with you, they're not the most well drawn out twins. In fact, I feel like I can draw better twins because one of these twins has T-Rex arms. It has a long body and long legs. This Castor has a giraffe neck. Look at that. It's kind of crazy. And we have long body and short legs. So they're not exactly the most identical twins out there, but hey, you know what? They're still twins nevertheless. And there's some really cool objects that we can see in the sky tonight in Gemini. And right now we have a couple of objects that we can look at. And probably the easiest one to look at first is the star Castor. Now, Frank, did we have a chance to get an image of Castor, or is it possible we can try tonight and see if we can see it?
Well, you know, I'm looking at the Beehive cluster right now, so I'm guessing we could probably get Castor too.
Okay,
if you
great.
Give me a minute.
Okay, Castor. One thing that's really cool about Castor is it looks like one star to our eyes, but when we zoom in on Castor, you'll see here in just a minute that Castor is actually one of 6 other stars in this 6-star system. Sexenary, I guess that would be the appropriate word. But it's a really incredible star system. Matt, could you imagine being in a solar system around a star that has 6 suns? It would be crazy, right? I mean, Frank,
Did it ever get dark?
I mean, it's very likely you would never get dark, right? I mean, Frank, you're an interstellar traveler, right? I mean, you're part of Starfleet, so you probably have traveled to Castor a few times.
Absolutely. It's a fascinating place. And, if you want to like do Star Trek references, if you've seen Star Trek Picard, there's like a reference to a star system with 8 stars in it toward the end. So it's not that far from the truth, people. Science fiction and reality are not quite as different.
We have a message from somebody real quick. Is it too late to see Uranus? And is it too late? I think it's fairly low in the horizon right now. Plus,
yeah.
The muck and clouds, it might not be too great for us. But maybe at the very end we can give that a try. But let's go over to Castor and see what we got.
Yeah, unfortunately, there is a cloud in front of it, but I do have an image of it that I took a couple of nights ago from the same setup. And there it is.
Okay, fantastic.
Yeah. So the stars themselves are actually too close together to resolve in a telescope, right?
Yes, exactly. Yeah. So you can see several of these stars surrounding the bright star Castor are actually stars that are going around that main star. And there's actually one star that's so close, it's kind of hard to see, but it actually looks almost, it's like a very, 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 very close star. It's really neat. Maybe we can zoom in a little bit here and take a look at this star system.
This is one of my favorites to show during our outreach events with the telescope because you know, the surprising thing to most people, they don't realize is most stars that you see in the sky are not just a single star. They're you know, binary or more. And when you look at Castor, you can definitely see the two different stars in the telescope. Different telescopes show different things. That's why there are so many models. And that's one of the things that Frank's got such a high-powered telescope that the brightness of the primary star is just kind of taking away from the other ones. But if you do have a telescope at home, take a look at Castor. You're going to need probably an 8mm or more powerful to render the two different stars, but it is a highlight to look at.
Definitely, yeah, and it's as Justin said, it is full of the sky is full of all different kinds of binary, trinary, and of course up to 6 star systems or more. And so this is a really great object to talk about, you know, how different solar systems and star systems are, you know, all across the night sky. Now, if Frank, if you want to go ahead and stop sharing, I'm going to go ahead and take a look back at Stellarium here. So Castor, people have asked me, how do you know Castor and Pollux? How do you know which one's which? Well, Castor begins with the letter C. So one of the things you can do is that over here on the right of Castor, there's this another star in this constellation called Auriga, the Charioteer. There's this nice bright star in the sky called Capella, kind of like a cappella, but you know, really it's just Capella. And if you look at Capella here, you'll see that it is closer to Castor, or the C star. And if we go over here, we have another star called Procyon, right here, Procyon. And this star, Pollux, begins with the letter P. So right over here, the star that is next to Procyon and is going to be Pollux. So that's one of the ways that you can kind of remember. Plus, it helps you learn a few more stars in the sky. It helps you be able to jump from place to place. Now, located kind of over in the area of Castor's foot is a really, really cool star cluster. It's an open star cluster like the Pleiades, but it's a little bit more tightly bound. There's a lot more younger stars, and this is called M35. So, Frank, if we can go ahead and try out M35, let's go ahead and do that and see what we can see in the telescope. And while we do that, Justin, do we have any questions that are happening on the Facebook Live that maybe we can answer while the telescope is getting set up for our next object?
We do have one. It's actually for Frank, though, if you want to multitask, Frank. But Douglas Leonard was asking if you had any filters that you were using on Castor.
No, on that it was just a luminance filter, so that's pretty much passing through everything on that one. And let me try and get that in the telescope here.
Now, while we're doing that, Frank, can you explain what a luminance filter is for some people that might not quite know what that means?
Sure. Yeah, so basically one of the tricks that we do in astrophotography is we take photographs through different color filters. So if you want to produce a color filter with a monochrome camera, what you do is you shoot a bunch of exposures through a red filter and a green filter and a blue filter. But another trick we do sometimes is what's called a luminance filter, and that just lets in all the light at once together. And that way you can just gather a lot more information about that object more quickly. It does cut out some wavelengths, you know, like infrared and UV light that you wouldn't see anyway. But beyond that, it's mostly just used to capture as much light as possible. And that's what we had in place for that particular image.
All right, fantastic. Yeah, so, and from what I understand, luminance also helps you, especially if you, maybe your night's not the greatest, or actually luminance is best to do on a really good clear night, because that's where all your detail comes in. So,
Right.
And what Frank is using tonight is a monochromatic camera. What that means is he's actually shooting through just the light. And then what he does is, if he wants to take a really pretty picture of an object in the sky, he will expose it not only to the luminance, but he will be able to, he also has to take in blue, red, and green light. and then we'll stitch it together to produce a colored image. So so astrophotography does take a lot more work than just taking a normal photo, but the reward is worth it. You get this incredible view of the night sky. So unfortunately, when we're doing these live star parties, we're not able to really expose in the red, green, and blue. But the luminance gives us the most detail. We get much better detail when we image through luminance. That's why we're using black and white. We're using that luminance filter to take these images, because it really enhances what we can see through the telescope. So that's kind of what we do too. Plus also black and white, you get more detail, you get more sensitivity, and you don't see as much noise either, which is also very, very important.
Yeah, and those filters play a role in visual observing too, right? You can use some of these filters as a trick to pull out more detail from things like the Orion Nebula. So it's not just for photography.
Exactly. Yeah. There's different. Yeah, definitely filters. You can use it to enhance certain nebulas, like the Horsehead Nebula we looked at last week. You can use certain filters to enhance some of the different types of gases that are found in those nebulas. So they really help quite a bit, and so you don't just use red, green, blue filters. There's also hydrogen alpha filters. There's all kinds of different other filters to filter out, and you can use some of these filters even when the moon is up. So actually, I think Frank, didn't you happen to use one of the filters for one of our objects tonight, like the jellyfish, or did you was that something you did with just luminance?
Yeah, when we get to the jellyfish nebula, that'll be an example of using a narrowband filter. So that's a hydrogen alpha exposure on that one. And actually, little secret, that picture of the moon we were looking at earlier was also through a hydrogen alpha filter.
Oh.
And the only reason for that was to try to cut down the light of the moon a little bit so that my camera wouldn't get overwhelmed by it.
Oh, excellent. See, there you go. Great strategy there. Of course, if you were looking through that, normally it would look red and it would look kind of weird. But thankfully we're doing it in a black and white monochromatic image, so it would look just, like you would see with the moon.
So M35 is stuck behind a cloud, unfortunately. Nothing to see there. I do have, there is the stars of the Beehive cluster are poking through a little bit, though, if you want to talk about that.
Okay, sure, yeah. So let's go ahead and show everybody the picture, the live image first.
Sure.
And the reason why is because just in case it does decide to get covered in clouds, we can get an idea of what's going on. So here we have the Beehive cluster. Now,
clouds.
in some clouds. So this is kind of a neat way of showing, we can still do a little bit of astronomy if we have a very thin layer of clouds that are going through. These clouds kind of came out of the middle of nowhere, didn't you? Justin, didn't you say you were just walking right before we started and it was beautiful out, and all of a sudden just this blanket of cloud just came over? So that's
that is Florida for you, ladies and gentlemen. And if you've ever wanted to get into astronomy, that is going to probably be, other than the price constraints of these expensive telescopes, it is the weather. The weather is your worst enemy a lot of the times.
Yeah, so the weather, that's the thing, is even if you look on the radar or the weather report, you'll say clear skies. Things can change very, very quickly. So keep that in mind, when doing astronomy. But again, as Frank was mentioning, we do have some images from previous events. So this is the Beehive cluster. And the Beehive cluster is this beautiful open cluster of stars. And another name for the Beehive is what we call Precipice, or the manger. And it's located right almost in the central area of what we call Cancer the Crab. Now, Frank, I don't know if you noticed this, but over on the top right-hand side, I believe that might be a little tiny galaxy photobombing the Beehive.
I did notice that, yes.
There you go.
I love when that happens.
Sometimes when you take these pretty pictures, you might discover little tiny galaxies. And there's another one up kind of towards the top center of it. If you look up.
Right there?
Yeah. So as we're getting away from the galactic plane of our Milky Way, we're getting into what we call galaxy season. And so this is a time when we're facing away from the Milky Way, and we'll be able to actually see intergalactic space. We'll be able to see all kinds of different galaxies out there in the universe. So sometimes when you take pictures, even star clusters, sometimes you'll get photobombed by a galaxy far, far away. See what I did there? We don't just do Star Trek jokes here. We also do stars. We don't discriminate between Star Wars and Star Trek.
No.
Equally important.
We are equally important, yes. We even support Babylon 5 for some of our viewers here that watch Babylon 5. I was a big Babylon 5 fan. I don't know how you both were, but I enjoyed Babylon 5. So we don't discriminate with any science fiction shows. You know.
And one of my favorite days are coming up, which is April 26th, LV426, if you're an Alien fan.
Oh, there you go. Yeah, see? There we go. Now, the Beehive cluster, again, is an open cluster like the Pleiades. It's actually a very, very large object. It's kind of hard for a lot of telescopes to get the whole thing in there. It's a very large field of view. And but you can actually see the Beehive cluster naked eye. It will look kind of like a faintish, fuzzy, almost out of focus area in the sky. In Cancer. So what I'm going to do now is I'm going to show you all where you can find the Beehive cluster using our special program here. So we're actually going to move over to the next constellation. Now, just over by the moon, you can see the moon here. And the moon is just to the left of Cancer. And located right here, you have Cancer. There's his eyes. There's his kind of pinchers. I kind of see that as that anyways. And what I'm going to do here is I'm going to search for the Beehive cluster. I don't know if it's in here or not. Nope, doesn't look like it. So the Stellarium doesn't always have every object in there. And there we go. We can kind of zoom in a little bit here. We can see. So right over here in Cancer, you can see just kind of next to these two bright stars, you can see the Beehive cluster, this beautiful open cluster right there. And again, if you were to actually look at that in the sky, if you have a dark enough sky, you can actually see the Beehive cluster with just your eyes. So that's pretty cool that we're able to actually take a look at that even with the telescope. Now, Frank, do you happen to have an image of the M35 going back to Gemini? Do we have an image of that?
I do not, I'm afraid.
Okay, well, that's all right. It's all right. Do we have anything else that we have available at the moment in Gemini, since we were looking at that?
Let's see. Where's the Eskimo Nebula? That's not in Gemini, is it?
It is, yes.
It is. Well, we have that.
All right.
And I'm actually trying to image it live right now. We'll see if we get lucky. I'm waiting for that first frame.
Try that. You know, why not? Let's see if we can get some of these targets with the telescope in real time, and we could resort to going to some of those photographed images. Let's try it. This is the nice thing about astronomy is sometimes you gotta wing it. You gotta see what will pop out. But while we're doing that, Justin, do we have any other questions from Facebook that we can answer?
We do actually. Heather was asking, how can you tell if something is a galaxy? You were so quick to pick that out, and a lot of our customers, yeah.
Yeah, Frank, can you bring that picture back up of the Beehive?
Yeah, sure. Hang on.
All right, that's a great question. So one of the things that we want to look for is structure. A star is fairly pretty much a pinpoint of light. Frank, if we can go ahead and kind of zoom in on the area where we found that galaxy, is it possible we can do that?
Let's see. I think so. By the way, this is only like 1 minute of exposure time too, so you don't need like super fancy exposure times to pick up these galaxies, which is even cooler. There's one right there.
So if you look at the stars, you'll see the stars are very luminous, very bright. They're almost perfectly round. And when we look at this galaxy, you can kind of see it kind of looks a little out of focus. It almost looks like it's a little blurry. But the other thing we're going to notice is we're going to see a structure to it. We're going to see that it actually has more kind of like an oval shape to it, a elongated shape, or more of an oval shape. Sometimes we have what we call elliptical galaxies, which kind of look like stars. Some elliptical galaxies are so round that they almost look like stars, but yet they have a diffuseness to them. They almost look fuzzy as you get away from the center part of the galaxy's core. So even elliptical galaxies, which are, some of them can be very round, still have almost kind of an out of focus look to them. But this one over here kind of looks like a spiral galaxy to me. And a spiral galaxy is like a spiral. It has the arms like our Milky Way galaxy, kind of like the most stereotypical galaxy you can think of. And if you look, you can see that object kind of has a little structure to it than just a star. So hopefully that kind of makes sense. Based when we look at this image here, you can kind of see some other structure to it than just a pinpoint of light or a bright point of light.
Yeah, and when we visit Leo later on, we can take a closer look at some other galaxies as well.
Right, yeah, you got some beautiful galaxies. So, maybe we can even do this one time. We can take just a random picture of the sky one time and see if we can find some galaxies. That would be kind of cool. One of our star parties is to just take a random part of the sky and see how many galaxies we could potentially find in that image. I think that would be a fun little thing to do. But we'll have to do that on a nice clear night with no clouds.
Yes, that would not be tonight. But yeah, normally you can just like point your telescope pretty much anywhere outside the galactic plane and they'll just pop up. It's amazing there's how many there are out there.
That's right. Yeah, exactly.
So we got clouds in front of the Eskimo, I'm afraid. So we do have this image from a couple of nights ago. Let me zoom in on it.
So today we had the opportunity to have a presentation done with a bunch of third graders. It was a lot of fun to be able to give a virtual planetarium program with a bunch of third graders. And one of the things that we talked about in our third grade show was how stars die. And our sun, which is a fairly reasonably small star, is eventually going to run out of the material in its core. And what's going to happen is it's going to essentially, the star is going to collapse. It's going to collapse, and eventually over time that material will float out into space. And left in the center of that dead star is a core, skeletal core, called a white dwarf. And that white dwarf's light will illuminate the gas as it floats out into space. And what we're seeing here with this image is we're seeing a dead star about the size of our sun, maybe a little bit smaller or bigger. We're not quite sure exactly the size of the star at one time, but it's around the size of our sun. And this star has exhausted its compression of a fusion that generates the energy that makes the star shine, and that star collapses, and essentially that material then fades out into space, and that's what we see here. And they call this the Eskimo Nebula. And honestly, I don't really know. Maybe it looks like, obviously Eskimo is kind of an old school name for the Inuit people. We don't necessarily use the word Eskimo anymore to identify these people, but I guess back in time when they noticed that they maybe saw maybe a face with like one of those large wool, jacket hoods or something like that. I don't know. That's the best guess I have.
Well, it is also known as the Clown Face Nebula, right?
That's right. Yes, it is. So yeah, definitely. I actually I can see that a little bit more than an Eskimo nebula there. But Justin, this is one of your favorite objects to show people in terms of a planetary nebula, right?
It really is. So it's fun to look at a star. It's also fun to look at a dead star, and you just it gives you a whole new appreciation for what's going on in our universe. That everything is temporary, and the light that we're seeing can sometimes be thousands or millions of years old, and to be able to see a star that once was is pretty spectacular.
Definitely, that's correct. It's pretty incredible that we can see and learn all these things, and for you all to see this. I mean, essentially, although we're using images we've taken a couple of days ago, this is essentially what you would have seen through the telescope as well. So it's not like we're enhancing it or we're doing any black magic in the background. This is essentially what you would actually see. Frank, I don't believe you did any sorcery to these images, have you?
None whatsoever. I was just doing a dry run a couple of nights ago for tonight's event and saved some pictures off fortuitously. This is exactly what you'd be seeing if the nights were clear tonight. And right now, I'm trying to get the Jellyfish Nebula. Looks like there's a cloud there too.
Well, Frank, can you take a second and explain what a cool situation we have for our audience? The fact that we are able to stack this light, stack these photons. I want to make sure the audience really understands what are they looking at? What's the technology that you've employed here to be able to see these things?
Yeah, I can talk about that a little bit. Let me go back to my screen here. Yeah, so just to give you sort of a high-level overview of what's going on here, we do have this telescope out of my driveway right now. It's being remotely controlled. It's a robotic telescope, so I tell it what to point at, and it will just point at it automatically. And right now it's pointing at the Jellyfish Nebula and trying to get some images of it. So what's going on here is that red thing on the bottom, there's actually a camera, a very sensitive, cooled CCD camera that's specialized for astronomy. And through the technology that we have here, what we can do is take a bunch of very short exposures, like 10 seconds or 30 seconds, and basically add them all up together in software to construct a more clear image over time. So basically, the more images that you stack together, as we say, the clearer the image gets. And this way we can get really clear images of deep sky objects that you could never see with your own eyes, and are also very, very difficult to see just with your eye through a telescope as well. So it really opens up the cosmos and lets you see things that you couldn't see normally.
Perfect.
And yeah, I mean, like I said, unfortunately, we've got some clouds going on right now. But just to show you how that would work, technically, I would go into my software here and go to the camera tab here, say live stack. You can see that I've selected the hydrogen alpha filter because, again, we're trying to filter through the emission from this nebula. And we're going to do a 30-second exposure and start it off. So what's happening right now is it's taking a 30-second exposure of this part of the sky. If the cloud cleared, we'll see something interesting. If not, we'll see a cloud. But as we get more and more of these exposures, they'll add together, and we'll just get a better and better picture over time. And if you want to...
Almost there.
Yes, 9 seconds, 8 seconds. We're going to get a beautiful picture of a cloud, I think.
Hey, this is going to be a beautiful, gorgeous cloud. Everybody, all at once, if you're watching, go ahead and go, wow, look at that.
Wow, look at that cloud.
Oh my gosh, look at all that water vapor.
That is beautiful.
H2O. You know, you can actually see a few things poking through it. It's more like a really thick haze, you know, so you can actually see a few stars. They're trying to get through there, but not enough to be
Frank, what did you do? You did your homework a little bit ahead of time to get these images for our audience, just in case we had some bad weather. Normally, that's what you'd be seeing in that very same image. So if there were not clouds, you would have seen this instead. And that is the Jellyfish Nebula. And Derek, if you want to talk about that.
Yeah, so the Jellyfish Nebula, it kind of looks like a jellyfish, just kind of upside down, floating in space. It's a space jellyfish. Yeah, imagine that. You're going to have dreams now of space jellyfish floating around in your cosmic dreams. Now, we talked about earlier about the Eskimo Nebula, and the Eskimo Nebula is basically the aftermath of a star about the size of our sun. But if you have a big star like Betelgeuse or a large, massive red giant star, it will continue to fuse elements in the cores of their stars to about iron. When it gets to iron, pretty much the star collapses and the star explodes, massive explosion, kaboom, into a supernova. And this material gets shot out thousands of light years out into space, and you have essentially this right here. This is a remnant of a massive supernova that occurred, and this right here gives us kind of a clue. And if we were to actually do a color image here, you would see all different kinds of elements in here. So the material that spewed out from this massive supernova would eventually gravitationally pull themselves together and form an emission nebula like the Orion Nebula. And from that material, there might be some hydrogen left over and some other stuff, and eventually that will come together to form new stars. Our sun technically is a second generation star. There's some other material in our sun. It's not a pure hydrogen star. And these supernovas are places where we have second, third generation stars that eventually will form solar systems like our sun did. So the universe doesn't waste. The universe recycles. And this is a great example of that. This is the jellyfish, and it's one of many different supernova events that we can see in the night sky. And both the Eskimo and the jellyfish are all located in the constellation of Gemini. And so there we go. So Frank, this is a colored image of the jellyfish, and you can see that's predominantly hydrogen there, but there are some other elements. You want to talk about this picture?
Yeah, this is actually a longer exposure taken through this very same telescope. So, you know, we were talking earlier about taking pictures through different filters. When you combine them together, you can get a color picture like this. But this is what we call a narrowband image. So what we're doing is we're looking at the actual emission lines of specific elements that are being ionized by that glowing gas that makes up this nebula. And in this particular case, red means hydrogen. But you can see some sort of like lighter colors here at the leading edge here as well, and that's caused by oxygen emissions as well. So, not only are these pictures pretty, they can also tell you about the underlying chemistry and chemical makeup of these objects as well.
Now, hydrogen and oxygen, Frank, what happens when you combine those two together? What do you get?
You can get clouds, water,
Yeah, you get water, exactly. So
H2O.
we, for
Yes.
the longest time, astronomers thought that water wasn't very prevalent. But we're discovering that water is one of the most prevalent molecules in the universe. There's probably water everywhere. And if you have water, you also have other maybe higher complex molecules like amino acids and proteins and different things like that. You may potentially have the ingredients to form life. So life could be the material necessary to form life could be found here in this nebula, the jellyfish. Pretty cool stuff. All right, so our last area that
We're all made of star stuff.
yeah, exactly. We're all star stuff. By the way, Justin, you were telling me last night about the new Cosmos series. You want to talk a little bit about that? You said you've been watching that, right?
Yes, yeah, Cosmos on Fox or Nat Geo, season 2. Well, technically season 3, if you're all fans of the original Cosmos. But season 2 is the whole theme is possible worlds. So season 1 really focused on what was going on now, what we've discovered, where we're at on Earth. This new season is all theoretical theory about different worlds that are out there based on new science that we've discovered, exoplanets. We're finding that even moons around exoplanets may even be more interesting than the planets themselves. So I highly recommend tuning into Cosmos if you can.
Excellent. Yeah, definitely do that. It's a great show. What I'm going to do now is I'm going to go ahead and share my our desktop here, and we're going to take a look at one final image or one final area of the sky before we final it up with Comet ATLAS. Hopefully, we'll be lucky to see that as well. So we've been looking at Gemini, which is right above Orion here. We looked at Cancer, and now we're to the left of the moon. We're going to look at the constellation of Leo the Lion. So I'm going to go ahead and bring up the artwork here. You can see our Nemean lion. This was one of the trials that Hercules had to do. As actually his first official labor. He had to wrestle and defeat the Nemean lion, and he was able to do that. He was able to wrestle it because he had to wrestle it instead of killing it with a sword or arrow, because the hide of this lion was said to be impenetrable. You could not actually stab this lion. You weren't able to actually shoot the lion with an arrow. It had to be wrestled with just his hands. He was able to do that, and after that, he skinned the lion and actually used it as an armor. And Hera, the queen of the gods, this was one of her treasured lions, and so she placed it up into the sky, as we see the lion today. But we can see a couple of things here. We can see kind of like a pirate hook shape right here. I like to think of it as a pirate hook shape. Think of Captain Hook's hook. That makes up the mane of our lion. Then we have a nice, beautiful, bright star here that's called Regulus. And Regulus literally means heart of the king. So that is, we have the heart of the king there. Down here, we have his back. And this star here makes up the nebula. And that literally translates to tail of lion. So the nebula. So we have the tail of the lion here. We have his heart. We have his head. And kind of over in this part of Leo is actually a very cool triplet of galaxies. And so what we're going to do now is we're going to go ahead and take a look at these galaxies. They're called the Leo triplet, Leo trio. They contain 3 galaxies, and maybe if we're lucky enough, we might be able to survey. There's actually some other smaller galaxies in there, and maybe we can look at those as well. So Frank, how are we doing on Leo? Is there any clear skies in Leo right now?
Well, you can see the scope's pointing at it, but unfortunately there's a cloud. So we are going to have to do the little trick of going back to the oven of the one that we cooked earlier. And let me pull that up for you.
That's our roll tonight. But
Yeah.
Thankfully, we did our homework and we got some great shots. Here we have the Leo triplet. Look at that. we can see all three of these galaxies here. So we have M66 on the bottom, M65 on the right, and we have this other galaxy, NGC. It's an NGC galaxy. These three galaxies here are the Leo triplet. The one on the left has a really funny name. You ready for this? This is the Hamburger Galaxy. Now, I don't know about you, but that kind of doesn't look like a hamburger to me, but you know, maybe that person was so hungry, anything that this person looked at looked like some food, but that's one of the names. What's really cool about this is we have a couple of profiles of galaxies here. The one on the far left, the Hamburger Galaxy, is looking straight on, or edge on. So we're actually seeing the profile of the galaxy on its side. So we can get a really good view of the dust that's in the galaxy. So all galaxies have dust and gases and things like that. And that dust, our Milky Way, if we looked at our Milky Way at the sky, we would see bright areas, but we'd also see dark areas. And those are generally dust that obscures the light from these stars. And that's essentially what we're seeing with this galaxy on our left here. We're looking on an edge on. So we're actually getting an idea of the size, the distribution of stars. But what's really neat about this is it's kind of hard to see in this image, but the Hamburger Galaxy is kind of curving a little bit. And that actually has to do with the fact that these two other galaxies are fairly close to it. It's actually gravitationally distorting that galaxy. Isn't that crazy? That these two galaxies are actually being distorted a little bit by those two other galaxies there. And the one on the top there, you can see that that galaxy, M65, that galaxy has more of what we call a broad spiral galaxy, a barred spiral galaxy. It has a very defined two large spiral arms with almost like a bar of stars that follow along the central area. And by the way, all of these galaxies have very bright areas in the center, and those we find supermassive black holes in the center of these galaxies. Really, really cool that we can see those, those dense, bright regions. Those are tightly bound by lots of stars, all being gravitationally pulled in by those, by that black hole. And the one at the very bottom is more of a normal spiral galaxy. So there's barred spiral galaxies, and then there's regular spiral galaxy. And that's the one we see on the very bottom there. It's more of a just a evenly distributed spiral arm surrounding the central core of that galaxy there. So we have some nice galaxies distributed through this whole area of the sky. But if we zoom in on this object, we might be able to pick out a few other galaxies. Frank, if there's a way we can zoom in, let's go ahead and zoom in on this and see.
Yeah, I actually have a deeper exposure of it too, if you want to go with that.
Oh yeah, let's go ahead and do that. Sure, yeah. There's actually more galaxies than just these three galaxies in this image. Frank, yeah, go ahead and bring up.
Curious of where that would be, but yeah, let me. Oops, wrong button. Hang on.
Don't do that.
No. Let's share this screen.
Oh yeah, look at that. That's really nice. Got some nice coloring in there.
Wow.
Yeah, beautiful. So if we zoom around, we might be able to pick out some other galaxies in here. If you look, Frank, look towards the bottom right, near the Hamburger Galaxy right there, you can see a couple of galaxies. So remember, for the person that asked the question, look in this area here and see if you can pick out the galaxy. Remember I told you about look for elongated shapes, diffuseness, maybe it's not as bright. Should be able to pick out three galaxies in here. Do you guys see those three galaxies?
Three. I see two.
There's
wow, you're better at this than I am.
You've got some good eyes, Captain D.
All right, so look at the two that Frank, go ahead and point out the two you see. Okay, go over to the left. Go to the left. Left, stop. Go up.
Oh, right there.
Ah.
Oh.
So you never know, yeah. And then technically there's another galaxy. If you go back to those two galaxies, keep going. Go down. Right there. That's an elliptical galaxy, yeah.
Oh.
Yep, that's an elliptical galaxy. That takes a little bit more training. to figure that out. But
I thought that was just dust on my screen.
How far away do you think that one is? That's got to be hundreds of.
It could be, hundreds of millions of light years away.
It's crazy that you can see that at all.
Usually, elliptical galaxies are older galaxies. So, yeah.
Ladies and gentlemen, that is a trained eye, Mr. Derek Scott.
Indeed.
So, all right. So let's go ahead and finish up our tour today with Comet Atlas. So we were looking at Comet Atlas last week for the first episode. What we're planning to do is every week we are going to look at the comet. This comet is actually getting closer and closer to the sun. And as it gets closer and closer to the sun, it will get a longer tail. It will get brighter as the ices and stuff get pulled off of the nucleus or the actual structure of the comet. It's going to develop a larger, what we call coma, which is this large kind of, hazy cloud around the central nucleus of the comet. And so let's take a look at Comet Atlas tonight and see what we can see.
Yeah, I'm just gluing the telescope to it right now. So let's see if we get lucky with the break in the clouds or not. So it should be pointing at it now, and we will activate the camera. Do a live stack. This one we're going to do we'll do a 30-second exposure. Luminance looks good to me. Let's give it a try. So now you wait in suspense for 30 seconds and hope for the best. If it's a cloud, we do have a image from a couple of nights ago we can show you instead. Shouldn't look too much different.
Frank, we've got a question from Mauricio. He was asking on the jellyfish what your exposure time was on that image.
Ooh, I don't remember. My guess would be around 6 or 7 hours. That's usually what I do on those ones.
That's a long time.
Yeah, fortunately, it's all automated. So the robotic telescope can just sit out there all night while I sleep and take pictures for me. And there's a cloud. So let's go back to our earlier baked image.
Well, everybody, remember, it's all about, that's why we always come prepared. We can say, hey, at least we get to look at some of these things tonight. And this was only like a day or two ago, right? So it's not going to change that
much. I think these were from Wednesday night, right?
That's right.
So this is going to change very much. But there we can start seeing more. There's a little bit more of a tail than what we saw last week. Not that much different, but it's expected sometime in May, if this thing survives, or if it gets really close to the sun. This could potentially be an outstanding comet. And so our plan is every single week we're going to be imaging. So what we're going to do starting next week is we're going to keep this image and we're going to compare it to the next week's image and start seeing some differences in each week as the comet gets closer and closer to the sun. So it's starting to look like a comet to me. What do you guys think? Is it starting to look more like a comet now?
Yeah, I remember last week you could barely tell there was a tail at all or which direction it was pointing. Like it was just sort of a hint of it, but it's a lot clearer this week.
A lot clearer. So it's only going to get
brighter, I think. Yeah.
It's going to get better and brighter, and hopefully it survives. Keep our fingers crossed. This could be an amazing event. We need it.
Derek, let's show our audience where in the sky they're going to want to look for this comet.
Yes. So, all right. So here we have I'm going to go ahead and get rid of the patterns of stars here, the lines. I'm going to get rid of I'm going to keep the labels. I'm going to get rid of the artwork. And we're going to go ahead and head over to the north. And we're going to look up towards what we see as a very famous object in the sky. A lot of people know about this object. This is the Big Dipper. Here we have the bowl, and here we have the handle of the Big Dipper. And we're essentially, let me do a quick search here because it actually helps me kind of, figure out the exact location. Essentially, the comet is going to be kind of over in this part of the sky right now. So it's kind of, if you look at Polaris right here, and you look at the ear of the bear, or in this case, there's the star Doobie. Yeah, that's a funny name of the star. But if you kind of look at Polaris and kind of point your binoculars or telescope in this general area, you should see kind of a faintish greenish out of focus star and that's the location of the comet. So the comet's kind of moving in this direction as it gets closer and closer to the sun. So it's going to be kind of moving in this way, and but it doesn't move. It's not moving that super fast, but it is moving. So if you were to actually take a series of exposures of the comet, you'll actually see the comet move a little bit. And maybe next week I was hoping that maybe at some point I can get some images of the comet and actually get some movement. So you kind of want to look over in the Ursa Major part of the sky, the Big Bear, what we call it, the Big Bear. So here we have our giant bear. This bear, for some strange reason, has a giant fluffy tail. I don't know about you, but I've never seen a giant bear with a fluffy tail before, but that's what it is. But you kind of want to look in this general area, peek around with your binoculars, look for through a telescope, you might see that comet. Now remember that comet is going to get brighter and brighter over time, and it will potentially become what we call naked eye, which means you don't even need to use a telescope to see it. But if you have a pair of binoculars, it's going to even make it that much more exciting and awesome.
Well, Derek, also tomorrow night we got something cool going up in the sky that maybe people will be able to see. The skies are supposed to be pretty clear.
Are you talking about the ISS transit? That's right. Yes. So yeah, let me go ahead and share my screen again. And what I'm going to do here is I'm going to go ahead and bring up International Space Station. This is a website that you can go to. It's called transit-finder.com. And we'll go ahead and leave a comment in the Facebook comments on this here. So Justin, actually, if you want to do that, it'd be great. Transit-finder.com. And when you get to this website, all you have to do is put your GPS coordinates. If your laptop or computer has a GPS device, or if you're using this on your phone, all you have to do is hit auto detect, and it'll be able to figure out exactly your location. Then you put down your dates, and what you're going to notice. What exactly am I talking about here? Well, the International Space Station travels across the sky, and sometimes the International Space Station photobombs either the sun or the moon. Now, tomorrow night, around 10:16 p.m., the International Space Station is going to photobomb or pass in front of the moon. So you actually, if you have a telescope set to it, you might be able to see a little quick pass of the International Space Station. So when I hit calculate here, it's going to tell me when the next one is. Again, it's tomorrow at 10. For my location, it's 10:10. Now, here's the problem right now that we're facing, is that because the International Space Station is so small, there is a path of transit. That's the path in which the International Space Station actually passes in front of the moon or the sun. Now, the 4-star rating means that it's a very, very good one. If this was only a 2-star, it wouldn't be so great. But being it's a 4-star, that means that the International Space Station is a little bit closer to us on the ground, which means that the profile of the International Space Station will be bigger as it passes in front of the sun. Now, if I hit show on map, this is going to show me the path of the International Space Station transit. Anything found in this blue line will mean that you'll actually see the ISS transit in front of the moon. Now, you can see my location here is in Lake Mary. So unfortunately, I'm not going to be able to see it. But I have some secret locations way, way, way far away from people where I'm actually going to be able to set up my telescope and look at it. But if you're located, say, in over here in Apopka, Winter Garden, if you're in South Orlando, near Millenia, if you're down by the airport, Lake Nona region, if you're in Lake Nona and Narcoossee, in this area, if you're located anywhere along that blue line, you will see the International Space Station pass by. Now, if you're located right here on the center line, that means the International Space Station will go right in the center of the moon, right across the center of the moon. So that's actually the best place. But if you're located anywhere in this blue line, you will see the International Space Station cross in front of the moon. Now, for example, what if I'm located in Lake Nona? What if I'm right here in Lake Nona? If I click that spot, it will tell me that it will occur at 10:10 and 32 seconds. It's very important to know this exact time, because if you don't get the exact time right, you will miss it. So what I would recommend you to do if you're doing this visually is to look at your phone's clock, and there's an app. Let me bring this up here. I'm gonna I think it's called Clock Sync. Clock Sync. It's an Android app. It syncs your phone with atomic time and the atomic clock. And atomic clock is the most accurate clock out there. And Clock Sync will sync your phone to the exact time that it needs to be, so you know exactly when this is going to pass in front of the moon. So if you are on your phone, you see that it happened. If it's at 10:09, what I recommend to do is put your eye in that eyepiece and wait and wait. And if you wait close enough, you might see, boom, this thing flying right in front of the moon. If you're wanting to take photographs, it takes a little bit more practice. It's a little bit tougher. But you can actually hook up your, if you have a cell phone holder, and if you hit the record button, you take video, you can actually get video of this, which is really, really cool. So again, give it a try, see what you can find. But transitfinder.com is what I use. Just look for this really cool event to see the International Space Station pass in front of a celestial object. So Frank, what do you think? You're going to give it a try?
That means finding a way out there, but that sounds like a pretty good opportunity.
You get beamed over there, right?
That's right. Beam me over.
Beam me
Absolutely.
over. There you go. Okay.
I'm curious, have you seen that go in front of the moon before yourself? Like, one thing I'm curious. Really?
I've seen it several times go in front of the sun, and I've gotten actually images of that. And let me see if I can bring up an image. I don't. Let me do that real quick here. You all keep talking while I look this up.
Yeah, what I was kind of wondering was the ISS itself is a pretty bright object when it goes over, and so is the moon. So, like, initially I'm like, is it going to appear as a silhouette as it passes in front of the moon?
Yeah, so here we have, this is an image I took of the ISS passing the sun. So it will look like a silhouette. You won't see the actual detail on the International Space Station, but you will see the profile of the International Space Station. You'll be able to actually see the solar panels and the structures of the space station. So you actually will see a profile of the actual space station. I think that's pretty nifty to be able to see that with your eyes, something that you normally don't see. And of course, Justin has a Lego model of the International Space Station behind him there.
It looked pretty close to me.
I think so. It might, you could get it passing your face.
Oh, there we go.
Transit Justin. Instead of that, it's more exciting than looking at clouds. I'd say that. Well, everybody, we are way past our time, but we've been having so much fun sharing you all the wonders of the sky. We don't really necessarily have a true time limit, but hey, it's all good. Do we have any last-minute questions before we finish up here? Do we have any other questions, Justin?
Well, this one was kind of thrown out to the group. I guess each one of us could answer this before we go. Stephen Smith asked, what was the most spectacular thing that you've ever seen in the night sky? We'll start with you, Frank. You've seen a lot. I mean, the pictures you've taken over the past year are mind-blowing. But what do you think? What's your favorite?
Gosh, it's hard to it's like choosing your favorite kid, I gotta say, probably one of my favorite things, I really dig really distant galaxies and really weird galaxies, right? Just the fact that you can see these objects that are hundreds of millions of light years away. And, we saw a little bit of that with the Hamburger galaxy earlier, where we had sort of this distortion to it because it was interacting with these other galaxies around it. And, just last night, every night I have a new answer to this because every night I see something new and it just gobsmacks me, right? So last night I was looking at something called the Hickson 44 galaxy group. And it's just this little group of 4 galaxies that are 80 million light years away. I mean, think about how far away that is.
Can you share us a picture that you took?
Yeah. Let me see if I can pull that up here.
Talking about?
Even better, yes. Picture, 1,000 words, all that. Let me see if I can share that.
And that is the distance, 80 million light years?
Yes, give or take.
Wow.
When you're dealing with these obscure objects, they don't always have a good measurement on them necessarily. But
sure.
Yeah, there it is. So
look at that.
It's not necessarily the most gorgeous picture you're going to see. I mean, like compared to the Hubble or something like that, but just the fact that you can see these things at all and they're so far away and you can actually see some detail on them. Like, look at this messed up galaxy here. Like it's like an S here, and something like really went by there and just dragged out the ends of that galaxy. This one's kind of messed up too. This one's not so bad. And then we have like this totally normal elliptical galaxy here too. And we have some photobombs in here too. So every day I have a new answer to that question. Like there's always something amazing out there to discover. And this is just what I happened to look at last night.
Well, I don't do a lot of astrophotography. Actually, I don't do any, but mine would probably have to be the 2017 total solar eclipse. I was lucky enough my uncle lived out in Salem, Oregon, and my wife and I went out there for that. And it was my first, eclipse. So everything I had read about it said, don't take a camera, don't take any pictures, just enjoy every second. And that's exactly what we did. And yeah, I wept a little bit. It was the most beautiful thing I'd ever seen. So Derek, how about you?
That's the problem is I've seen so many things, but I'll give my top three. How about that? Number one, the Aurora Borealis. I got to see it a few months after my dad passed away, so it was a very emotional time for me. But being able to see those curtains of light dance, it's just magical. I can imagine ancient people thinking that it's just magic. I mean, it's just, there's nothing to do. We know the science behind the aurora, and it's the exciting electrons that are getting excited and calming down and releasing light in our upper atmosphere and different elements. But it doesn't matter. It doesn't matter the science. I know all the science, but to be honest with you, seeing it's just amazing. The solar eclipse, Justin, just like you, it was one of the most, being with my wife and my friends and out there in Idaho and seeing this, and it was just incredible. Astronomical objects. I was fortunate enough to see the transit of Venus for a split moment. And that alone was really, really cool, knowing that was the last time I would see an event like that in my lifetime. That was the most recent Venus transit. Just like Frank, anytime I look at galaxies or anything, even just staring at the Milky Way at night, under a dark night, seeing this Milky Way in Chile, you just really feel connected to the universe. It's just amazing. Just all the things that I'm made up of, you're made up of, are found in the universe, and just being connected to that is just an amazing experience, and being able to share that. And that's one thing that Frank and we are both astrophotographers. I can't speak for Frank, but for me as an astrophotographer, the thing I love about it the most is being able to share this with everybody and to get them to just see this. Look at this. This is amazing. It's a galaxy, and that galaxy may have a planet like Earth that people might be doing a virtual star party there. You never know. It's just incredible to think that, what could potentially be going on in these far away places. And so that's a great question. And if you happen to know, if you have a moment, leave a comment on the Facebook page or on the Facebook video feed. If there's any incredible moments that you've had, even just seeing a meteor shower, like the one we saw, the Gemini meteor shower a couple of years ago. Remember that?
Oh, wow.
Frank,
Yeah.
were you there when that happened?
Yes.
Yeah, it was just incredible. I mean, seems like every 5 seconds there was a meteor. It was just unbelievable. When you see a meteor shower, meteor storm, that's incredible as well. So there's so many different experiences, and each day is, as Frank said, is just it's just what incredible thing am I going to see today? And today we got a chance to see the Pleiades next to Venus. How cool was that, right? And all three of us ran out right before we started tonight, going, we need to go out, we need to look at it, we need to see it, and it was truly spectacular. Well, I want to thank all of you for coming and joining us this evening and hearing three guys talk about astronomy. Next week, we have a little bit of a different type of program. Not only are we all three of us going to be meeting, but we're going to have a special guest. And if you are a fan of the Planetarium for many, many years, you might remember a gentleman that worked with me at the Planetarium, Michael McConville. And he's actually going to be joining us next Friday to talk about the planets. We have Venus up in the sky. I'm also going to be imaging Mars, Jupiter, and Saturn in the sky in the early morning for the next week. And I'm going to be able to show you all those images, because unfortunately we're not going to be able to look at that live, because unless everybody's okay with doing a 4 a.m. virtual star party, I'm up for it if you all are up for it, but I'm sure most of you will be sleeping around then. But so I'm going to go ahead and get up early in the morning, get those images, and I'll be sharing those with you all next week. And Frank, I'm sure we'll find some other cool stuff to look at too, using your awesome telescope. And so I hope that you tune in to us next Friday at 9 p.m. For our next virtual star party. And don't forget, we also have virtual planetarium public shows on Thursday nights at 7 p.m. So if you like what you see here and you want to check out some other cool stuff, we're going to be touring the planet Mars next Thursday at 7 p.m. So join us for that. But with that, I want to thank you all for taking this moment and joining us tonight. And with that, I'm Captain D. And live long and prosper from Engineer Frank and Commander Justin. And with that, be safe, live long and prosper, and we will see all of you next time on our virtual star party. Good night, everybody.
Good night, everyone. Be safe.
Be safe.